Okay, so here's some guess and test problems. Now these can be really painful, but I don't think they're so bad if you think about the pairs that have to work together. As long as your variables match, then you have to be in a pair on the unit circle. So that means that 1/2 and radical 3 over 2 always have to happen together. That means that 0 and 1 always have to happen together. That means that radical 2 over 2 and radical 2 over 2 have to happen together. And so if you think about what those pairs are, the guess and test and just switching the order and adding in some negatives, the guess and test shouldn't end up being that bad. The thing that may be a little painful for you is that these are always fractions, almost always fractions. So we have to be a little careful. So I'm going to make this into a fill in the blank for us. And I want this to equal 2 eventually. All right, and now try something. Really, these don't get easier unless you try something and figure out what works and what doesn't. So I know, I've done this problem before, so you have to bear with me a little bit. I might go a little too fast, and you can always come and ask me a follow-up question in class. So I know I want to go from a radical, because there's a radical in front of the sign of x, to a whole number. So here's the thing. The only thing that gets rid of a radical is squaring it or multiplying it by a like radical. So when I see this radical 3 over 1 times something, I'm going to try this guy, radical 3 over 2. And if sine is radical 3 over 2, then cosine has to be 1/2. I think having those options written on your paper for you in the pairs is very, very helpful. Okay, so as I simplify here, radical 3 times radical 3 is 3. 1 times 2 is 2. Okay, 3 over 2 plus 1 over 2, that's common denominator, that's 4 over 2, which is 2. So I'm going to go ahead and log what value that is of x. So sine is radical 3 over 2, cosine is 1/2. So over a little, up a lot, that's at pi over 3. So I found a solution. Now what I think through is negatives would work here. So if this was a negative radical 3 over 2, that would make this a negative 3, and then that is not going to work. That is not going to be a 4, it's going to be a negative 2 over 2. So that's how we would get a negative 1. That's not going to work. If I had a negative 1/2, then that would be a negative 1/2, and that would not be a 4, so that wouldn't work either. If I had 2 negatives, we'd get a negative 4 over 2, so that would not work either. So I think the only way I can make this happen is pi over 3. The other thing you could check is the 1s. 0 and 1 are not going to work either. So pi over 3, since that's the only solution, plus 2 pi. So keep those options in front of you while you work. All right, sine and cosine are equal to 1/2. This is a multiplication problem. So I'm going to set it up just like I set up the last one. Maybe give myself a little room in between. Oh man. Give myself a little room in between to do some simplifying. So if I think about my pairs, 0 and 1, radical 3 over 2 and 1/2, and radical 2 over 2 and radical 2 over 2, I can get rid of 0 and 1 as options. Those aren't going to multiply to 1/2. Radical 3 over 2 would multiply to radical 3 over 4. So that's not going to work. So let's look at radical 2 over 2 in itself. Radical 2 times radical 2 is just 2. 2 times 2 is 4, and that is 1/2. That pair happens at pi over 4. Now, what else is going to make that happen? Because there's another spot. 2 positives are going to multiply to 1/2. So are 2 negatives. Negative times a negative is a positive. So pi over 4 works. And the third quadrant, fourth, works as well, because that's where sine and cosine are both negative. And that is 5 pi over 4. Pi over 4 and 5 pi over 4 are right across the unit circle from each other. So to write your general equation, you're going to do plus 5k. For 13, if you haven't tried this one yet, go ahead and try it. Please pause the video and make an attempt. All right, hopefully you tried it and you're just confirming. And hopefully you decided that you have to use 0 and 1. So how are we going to add these to 1? All right, well, how about 0 and 1? That will definitely work. Negative 0 is just fine. So 0, 1, that's where cosine 0 is 0 and sine is 1, and that's going to happen at pi over 2. Now, there are other places this also works, so I'm going to erase and keep going. So we did 0 and 1. I guess I should keep track of what we used. All right, what about 1 and 0? So we're trying 1 and 0 right now. 1 negative, because of this negative, that's not going to work. So 1 and 0 is not going to work. But if I use negative 1 and 0, that point at pi, those two negatives are going to cancel. All right, so I've tried all my quadrantals except for 0 and negative 1. So let's see if that one works. And this is where guess and test is really kind of guess smart and test. Negative 0 minus negative 1 is not going to equal 1, so that one's not going to work. So here are your two solutions, and these look really weird to me typing. Pi over 2 and pi. And they are not pi apart. So you're going to do plus 2 pi k for both. So number 14, you can do as a guess and test problem. It looks really crazy. But you can do it as a guess and test problem, or you can do some algebra. I'm going to do some algebra. So I'm going to combine my like terms first. I see all these signs, so I'm going to start moving my signs. I put this problem on here to show you that if you have a guess and test problem, just because it says guess and test, doesn't mean that you can't kind of algebra yourself out of that issue. Okay, so I got rid of one of the terms. That's looking a lot cleaner. You could work with this, but I'm going to see if I can do a little more here. See if I can do some more algebra to get myself into a place that's a little nicer. All right. So that's not a ton nicer. I kind of like the equal sign in between. What I can do here, though, I'm seeing something that might end up kind of nice. So sine over cosine is tangent. So if I can divide both sides by cosine, I can get rid of the fact that this is a guess and test problem, and I can solve a tangent equation instead. And I don't know about you, but I'm feeling a lot more confident about tangent than I am about guess and test. I just think tangent is easier to work with. It's something I'm a little better at. I like it. And then if we divide both sides by radical 3 and rationalize, so what we have here, tangent of x, just to mess with my order here a little bit, negative 3 over radical 3, bring that radical up, was a guess and test problem. You can absolutely go back 3 steps into a guess and test. I was able to turn this in algebra myself out of the guess and test on this particular problem, and so I think solving directly is always easier. So here, tangent is radical 3 at our pi over 3's. Tangent is negative in quadrants 2 and 4. So our quadrant 2 pi over 3 is 2 pi over 3, and our quadrant 4 pi over 3 is 5 pi over 3. Those are pi apart. This last problem is definitely a guess and test. The radical 2 here should be a big flashing sign to you that you need to work with radical 2 over 2, radical 2 over 2 as your pair. So how can we make this happen? All right, I'm going to do radical 2 over 2 plus radical 2 over 2 and see what happens. It's called guess and test because you just got to work it. Pick something, try it. You won't get further away from the answer. So we have a common denominator of 2. Don't get so excited about being close to the end that you make that 4. I have radical 2 plus radical 2. Remember, radicals work like variables. We add the numbers out front. That's one of them and another. So that's 2 radical 2's. So this was lovely. It didn't get me to the final answer, but it did get me ridiculously close. So it didn't give me a negative radical 2, but it did give me a radical 2. So what do I need here? I need the pair where these are both negative. I can't have one negative and one positive. That would just add to 0. So if I have a negative 1 radical 2 and another one, then I have negative 2 radical 2's. And then those 2's cancel, and I have negative radical 2. So sine and cosine are both negative in the third quadrant, and the third quadrant, fourth, is 5 pi over 4. Please see me if you need more explanation on any of these problems. If you watch these videos, though, any videos that you watched, any problems that you couldn't do on your own, those are great problems to go back and rework. Like, cover them up now that you have the right answer, rework it from scratch, and peek back if you need to. If you don't need to peek back, you're good. If you do need to peek back, then you need to do some more examples. All right, let me know if I can help.